Welcome back to the shop, everybody. A few months ago, Justin, who's one of the hosts of the Home Shop Machinist podcast, did a video for his YouTube channel, The Cog Wheel, that was about rust bluing in the home shop or black oxide coating in the home shop, depending on how you want to look at it. And that's a process that's of interest to me because, like a lot of home shop machinists, I make a lot of tooling for myself. And I want to be able to protect it from rust. So I tried the method that Justin presented, and it worked pretty well. And I think the only thing that didn't work as well as I wanted it to was actually an issue on my part. So it is a good process as far as I can tell. If you want to learn more about it, go check out Justin's video on his YouTube channel. So I narrowed my problem down to not properly removing the rust, the excess loose rust, while actually going through the process of black oxiding a part. So what I've gone ahead and done is bought one of these, which is a carding wheel used by gunsmiths or home shop gunsmiths, if you will, to rust blue barrels and whatnot. And really all this is a wood hub with really, really fine stainless steel bristles. Each of these bristles are only 2.5 thousandths of an inch in diameter, so they'll be pretty gentle on the part. However, one of the things I don't like about it is they use a little tiny arbor hole here, which is only 1/4 inch, and it's not really a 1/4 inch because this is a 1/4 inch bolt. And it's super sloppy. And this is an F-size drill, which is 0.257. And it's still got a little bit of slop in it, but not real bad. So we know this hole is not actually a 1/4 inch. Not to mention, it seems that the recommended or most common method of actually mounting and spinning up this wheel is to put a 1/4 inch bolt through it like this, put another washer and nut on the other side, and then chuck it up in the drill press, which I'm not overly fond of spinning something, that weighs a pound or two up to 3,600 RPMs on a bolt mounted in a drill chuck. The bolt's not designed for that, and neither is the drill chuck. So what I'm going to do is I'm going to make a dedicated arbor for this, and I'm not going to use it at the drill press. I'm going to use it over at my wood lathe. The reason for that being is that my wood lathe has a Morse Taper 2 taper in the headstock. So I've gone ahead and bought a Morse Taper 2 1/2-inch collet, and I'm going to make an arbor that'll hold the carding wheel several inches away from the headstock and hold it a lot more securely so that I can move in and around the part as needed and not worry about some flimsy bolt breaking or letting it spin or just, not having good concentricity to the spindle. So the first thing I'm going to do is I'm going to take this over to the milling machine, and I'm going to open up this hole so that I can use a more substantial arbor. So let's go over here and I'll show you the setup I have going. Okay, so I've got everything set up. Let me explain what we got going on here. Underneath, there's a piece of scrap aluminum that's mounted in the vise, and I actually went ahead and faced it off so it's perfectly perpendicular to the axis of the spindle. I went ahead and took a larger than needed drill bit and drilled through that for clearance. And then I took a small drill bit, the F drill that fits this hole as tightly as I can get it, mounted it in the chuck here, and then used that to center the carding wheel while I was clamping it down. So now what I'm going to go ahead and do is drill through undersized. What size is this? I can never remember this. 23/64. And then to be completely ridiculous, I'm going to come back through with a 3/8 inch reamer. So it's been a couple days since I started this project, because I actually started machining a different blank, and then I realized that the way I was doing it was suboptimal. It was going to lead to errors because there were too many steps, too many changes in setup. So I'm going to start over. So the first thing here is to go ahead and face the part to length, or I should say the blank to length, and then we'll come back and center drill it. So according to my measurements, I've got 22 thousandths to take off one of the ends. We'll do this one. And then I can center drill it. So one of the issues with my previous setup was the stock's too big for this smaller drive dog that I have to mount. It simply, you can't get it through. So I had to use a bigger drive dog. And it's really probably too big for my machine without some counterbalancing. And then while I was actually doing the turning, I thought, what am I doing? I could just rough turn this down to a size that this can fit on, and then I can use the smaller dog and spin the part at a much higher speed, because I don't have to worry about it being out of balance. And I can do things in a fashion I'm more used to. So that's what we're going to do now. I'm going to center drill this end, and then we will rough turn this size down just big enough to get the dog on it, so I can flip everything around and mount it between centers and rough turn everything and try and keep the shaft as concentric as possible. Okay, that's about 1/8 of an inch oversized, which is still way more than I need to leave on, but I want to keep it as rigid as possible, and that should be fine. So now I can tear this down and mount up the drive plate, and then mount this bar up between centers and do the rest of the work. Okay, I've got everything mounted up now. I actually remember now why I have two small dogs like this, and one of them has a tapped hole in it, and that's because To actually use this small dog with this center, which is longer than normal, shall we say, you've actually got to extend it out. So first thing here is to rough in this end. So that's that end rough to size. I'm going to flip this around and then we'll go at the center section here. I've gone ahead and taken a skim pass on the center section, and well, after I flipped the part around, and now it's time to go ahead and bring this down to final dimension, because this is 1/8 of an inch oversized, where everything else is 20 to 30 thousandths over. So we'll bring this down, we'll flop it around one more time, and then we'll bring this end and the center section down the size. And this should be the final pass. I've gone ahead and flipped it around. I've taken some passes on this end, and I've got it down to where this should be the last pass, hopefully. Let's see how I did. And that is within spec. Excellent. So now all I need to do is mount up my vertical shear tool, which is what I've been playing with on this. I like the finish it gives. Plus, since we're machining out here in the middle, I want to take really light cuts because, you know, this is only 3/8 and this is a 1/2 inch, and that's almost a 6-inch span. So there is going to be some flexing. last step here is just to go ahead and polish up this center section, and it's really not something you need to do, but I want to, so that's what I'm going to do. That looks nice. Now all I got to do is tear this down or remount the chuck. And I just have to drill and tap this end, and then the shaft will be done, and then we'll make a custom washer. I've gone ahead and remounted the chuck. I've mounted the arbor in the chuck, and now I'm going to go ahead and drill and then tap the carding wheel end for the Allen bolt that will hold it in place. So that's the hole drilled. Now it's time to tap it. This is a 10/32 spiral flute bottoming tap, so it should make pretty quick work of this 4/16 stainless. Little tap magic, never hurts. There we go, bottomed out. There we go. So that's it for the arbor. Next step is to make, let me grab the right wrench. Next step is to make a thick washer, which I have a neat trick for that. So the first part of the trick is to face off the end of this bar. This is just the same piece of 4/16 bar stock that I used to make the arbor. I've got a nice clean face now. Now it's over to the bandsaw to cut off a chunk of this that's longer, or I should say thicker than I need it to be. So I'm back from the lathe. Here you can see where I've sawed a piece off. You can actually see my Sharpie marks where I was doing the scratch the little line so I can get an idea how long to make it. First thing I gotta do now is face off this rough sawn end to a known distance. Okay, so let me put a pair of gloves on and then I'll show you the trick. I mean, this is nothing new. Other people have done it for other things. If you follow Click Spring, he does this quite a bit for stuff, but usually slightly differently. So now we've got a nice, smooth, clean, square face on this piece of bar stock in the chuck. And on the other end of the piece that I faced off before I bandsawed it off. So what you do is you take a little super glue. This is why the gloves are important. That's probably actually way too much. You push it on everywhere and get it nice and evened up. Just hold it in place for a little bit. Come back in a minute after this sets. So the super glue has set up probably enough that I can machine this and not have to worry about it letting go, but I'll still have to be careful. Make sure I don't generate too much heat. Now the benefit of this is because I faced off the chunk of bar stock that's actually mounted in the chuck before I super glued this other piece to it, I now have a definitive zero that I can face back to get this, what will be eventually a thick washer, to a very specific thickness. In this case, 200 thousandths. So let me start by facing this to size and then we'll turn it to diameter. So now it's cleaned up all the way around. I can take a measurement. What did I do with my calipers? So the next step is to chamfer this. It's purely decorative. So you don't even really have to do it. It makes it look a lot better if you do, though. One of the side effects of having a lathe, it's not really rigid, is you can't make a big chamfer like that. This is okay. I'll come back and hit this with a file, try and make it a little bigger, and then I'll drill it and tap it for the clearance hole. So I got some good news and some bad news. Good news is it works. Bad news is at the end of the arbor, there's about anywhere from, well, it depends on how you orient the arbor relative to the collet, from about 2 thousandths run out to about 5. And I've checked the arbor. The arbor's fine. I checked it over at the surface plate with some V blocks. It's got at most 4/10 worth of run out in it. So I'm pretty sure it really comes down to the fact that it's a wood lathe. You know, this isn't a hardened and ground spindle taper. I mean, you can see marks in it. It's not a high-end collet, so multiple inches out from the spindle nose, you're going to have some run out. But 2 to 5 thousandths is fine for this. So let's go ahead and mount it up, and I'll show you what it looks like. Collet's in. The 1/2 inch diameter end just goes into the collet. It'll seat fully down in. You don't want to get too close. You want to leave a little bit because you got the nose radius from the insert. That should be more than good enough. Mount up the carding wheel. And now the thick washer, which did turn out really nice. And then the button head cap screw. Lock it down. See, no, that's all the way up. Let me turn this down. So that's only about 200 RPMs, which is way too slow. 1800, 2000, 3000. That's 3600. There we go. That's about 2000 RPMs, and that's probably where I'll use it, somewhere between there, maybe 2700. But overall, I'm real happy. The arbor's out here real far, so I can get in and around the wheel and work parts as needed. And really, if I wanted to, I could go and get just a regular 10-32 bolt, or I could make my own and just mount the wood lathes live center in here and, you know, put a little center in that, and then I could have it supported from both sides. But you really shouldn't be bearing down on the wheel like that for carting off the rust, as far as I can tell. So this should be good. In my next project, hopefully I'll get to use it.